To start off, what we in grade 8 and 9 call geometry, and then later on we'll be calling Euclidean geometry. So just for reference, the word Euclidean comes from the person that they named Euclidean geometry after, which was Euclid of Alexandria, like in Alexandria in Egypt. But we don't really in grade 8 and 9 like distinguish between Euclidean geometry and the other geometry that you only start in grade 10, which is analytical. So it's irrelevant for now. But yeah, before we can start, we need to just go over some of the terminology so that we know what the words mean and how we write certain things. So to start off, a point. A point is a dot, right? Okay? And usually when we're talking about points or vertices, we'll get to that in a moment, we use capital letters. For example, capital letter A. Points are capital letters. Then a ray would be from a point pointing in some direction. Okay, that should be a straight line. Let's pretend it's a straight line. And we indicate a ray with an arrow to show that it continues forever and ever. Okay, we would also put some capital letter there by the point. Then a line segment. Okay, maybe let's quickly do a line first. A line is just a line. It doesn't have to be horizontal, right? Lines can be vertical, diagonal, whatever. Anyway, but a line segment would be a specific like portion from a line. So it has an end point and a starting point, or starting point and an end point. So if you talk about a line segment, so line segment, and we use capital letters A, B, it means it's the line between point A and point B. Then angles are measured in degrees. Okay, this we should know. Okay, not degrees Celsius or Fahrenheit or Kelvin and it's like 30 degrees. And then we said earlier about vertex. So there is a difference between a vertex and a point, in the sense that a vertex is where at least two lines meet. So this over here is a point. Let's say this is point A, but it's also a vertex because two lines are meeting at that point. It could be more also. And again, vertex, because it's a type of point, capital letter, please. And then when we name an angle, okay, so for this, now these are two rays, but let's change this just to points, so it's a bit easier to work with. And we call this point B, and this is point C. Then to name this angle, you can either say it is angle A, with like a copy, I think it's called a hat in English, a copy on top of it. Or you're allowed to put the angle symbol in front of the letter. Okay, so because there's only one angle A here, and it's that one, you can name it like so. But sometimes you are forced to give it a bit of a longer name, and you will say, so A is where the angle is, right? A is a point. It is an angle and has a copy on it, and we mean that angle. But this angle over here is basically there by point A, but it's between point B and point C. So then you put B and C around it to say it's the angle BAC, or you can say CAB. The order doesn't really matter here. But the one in the middle and the one that has the copy is at which point you have the angle. Or of course you could have put the angle symbol in front, so angle BAC like that. Again, the point or the letter that's in the middle, at that point you have the angle. This becomes especially important if you maybe have like two lines. So this is A, B, C, D. If you want to talk about this one, and maybe there's point E is that one in the middle. If you want to talk about this angle over here, it's AED, where this one is AEB, and so forth. So this is where it becomes especially important to be able to read and produce this notation. If there's only one angle, this one is fine and easier. And some terminology with regards to how we name angles. So we should kind of be familiar with these words. If you're Afrikaans, then these will be a shock to you maybe. But if you're English, you should be kind of used to these words. So an acute angle, like a cutesy angle. is a small angle that's between 0 degrees and 90 degrees. So like for example 50 degrees or 33.59 or whatever. Okay? If it's in between 0 and 90, we call it an acute angle. We classify it as an acute angle. If it's exactly 90 degrees, okay? I know we haven't really gone into depth with inequalities yet at this point in time, but if we meant it can also be equal, we would have put it in line there underneath. Okay, this means angle ABC is less than or equal to 90. But we only have less than or smaller than. Okay. Then a right angle is exactly 90 degrees, and we call the angle a right angle. But we can say the arms or the line segments or the rays or whatever of AB and BC are perpendicular, okay, which means they form a 90-degree angle. Okay, so the lines are perpendicular to one another, but the angle is not perpendicular. The angle is 90. Okay, and then over here, just this upside down T, that is our symbol for perpendicular. Then we have an obtuse angle, which is going to be bigger than 90 degrees, but smaller than 180. So anything that is bigger than 90, but smaller than 180. So we've done exactly 90 degrees, but we also have exactly 180 degrees. If we're talking about an angle, it's a straight angle, but if we're talking about a line, it's a straight line, okay? The straight angle forms a straight line, basically. Then we get a reflex angle. So if it is bigger than 180 degrees, but smaller than a whole revolution, which is 360 degrees, then we call it a reflex angle, which is why we said earlier, this is the only angle here, and you can call this one angle A. Because if we meant this one on the outside, we would call it reflex angle A. We will usually, if we talk about angle A or angle whatever, then we mean the one that's less than 180 degrees. So either the acute or the obtuse or the 90 or the whatever. If we meant the outside angle, the reflex one, we would say reflex angle A. Okay, or also reflex angle BAC. That's another way you could have named this, or CBA or whatever. And then we already said a revolution is a whole 360 degrees. Now we've done all the classification of angles, but there is a little bit more theory that we have. And that's when we talk about the relationship between angles at the same vertex. Okay, they have to meet at the same point. Okay, very, very important. So if we talk about two angles that share an arm or line in between them, and they are at the same vertex, both have to be true, then we call them adjacent angles. Adjacent, next to one another, and you can abbreviate adjacent as just ADJ. Then we also have complementary angles. Again, for you to have complementary and supplementary, they have to be adjacent first. Okay, so these are like further classifications underneath adjacent angles. So if these adjacent angles form 90 degrees, so when you plus them, they're equal to 90. For example, 60 and 30, that gives you 90. And they share a point, they are adjacent. Then we call them complementary, which we abbreviate as comp or complementary. And then similar to complementary angles, we also have supplementary angles, which is usually sup or supple. The abbreviation is when we add them up and they give you 180. So for example, 90 and 90 or 180. So let's quickly take this complementary and supplementary and we'll look at the next few examples just to be able to identify them. Okay, so here we are given a few angles. And every time we have to say, are they complementary, supplementary, or neither? So my advice is quickly pause here. Try and see if you can do it yourself. We're going to see if these angles are complementary, supplementary, or neither of the two. Here we have 34 and 146. So we are going to add them together and see what we get for an answer. And that's what we're going to do with each of these. When we add them, we get 180 degrees. Therefore, they are supplementary. Do it for the next B, C, and D also. Let's see what we get. So for B, we get 90. Therefore, we say they're complementary. 99 is neither complementary nor supplementary, so you say neither. And similarly, 182 is also not 180 or exactly 90, so it's neither. Okay, now this, I think, is going to confuse a little bit more people. So we're going to add them together. So we have 2x plus 30 plus 60 minus 2x. When we add, and we are working with different types of terms, okay, so maybe we have x's and we have numbers and whatnot. We have to add those that are the same type, the like terms. So both of these have x's in them, and we have 2x minus 2x. That gives us 0, right? So all we actually need to do is add those two together, which is 90. So therefore they are complementary. Similarly with this one, we have p plus 90 minus p. When we add p and we minus p, we get 0. 0p, which is the same as 0. So this is also 90, so it's also complementary. Another type of question they could have asked us is to find the complement or supplement, okay, of a specific angle. So, for example, if they give us 65, then to find the complement, we're going to say 90 minus 65. We're going to get 25. Therefore, the complement of 65 is 25, because when you add 65 and 25, you get 90. So similarly for the supplement. Okay, this has nothing to do with vitamins. And then the supplement will be 115, because again, when you add those two together, you are going to get 180. They can also ask it with like an algebra type question. So maybe say x plus 30. Then you will say 90 minus, and you put brackets when you put x plus 30 in there, because this minus is going to change both signs. So we're going to have 90 minus x minus 30, right? The minus 1 gets multiplied with each term and changes both sides. So now we have 90 minus 30 is 60, so we have 60 minus x. And similarly for the other one, you'll say for the supplement 180 minus x plus 30 in brackets, because the signs are going to change. We get minus x minus 30. So we're going to get 150 minus x as the supplement of x plus 30, because again, when you add them, the x minus x will be 0, and you have 30 plus 150 is 180.